Welcome back to Quest EduPhysics students. Today we are discussing about the movable pulleys. In this video, we are going to learn about the movable pulley. The Atwood machine is a fixed pulley. You know that. Here, what is the movable pulley and how it functions, we have to know. As same what we did in fixed pulley, we are going to find out the tension and as well as the acceleration of the system. But we will do in different way, and finally we will get some tricks to solve the equations very easily. Here let's say it's a rigid support, students. Okay, here we have a pulley and we got one more. Okay students, it's one more pulley. It is fixed here. Okay, and we suspended a mass and we attached another mass here. Okay students, let's say it is mass m1 and it is mass m2. Okay students, we have to find out the tension in the pulley and as well as the acceleration. Here these arrows are indicating the tension, and let's say is the acceleration, and it is the direction of the acceleration. In this case, if you watch it carefully, m1 is less than m2. The main purpose of pulley is, by doing less work, we have to lift more weight, students. Doing the less work, but we are lifting more mass. Okay, that's why intentionally it is shown in this way. Okay students, let's say the length of the string which is attached over the pulley is equal to L. Okay, the total length, I am taking it as the L. L is length of string moving over the pulleys. Okay students, L is the length of the string which is moving over the pulleys. If it was this is the fixed length. Okay, and here also a fixed one. Here this part doesn't move and the remaining this one will move. Okay students, let's say this length as y2, obviously it might be equal to y2, and this one which is moving over, call it as y1. Okay students, then we can write the total length L must be equal to, let's say this length, I am taking it as y0, it is a fixed one, y0 plus y2 plus y2 plus y1. Okay students, and it can be written as L is equal to y0 plus 2y2 plus y1. Okay, is the total length of the string, students. Here it's all happening in a given interval of the time. Here we are differentiating this length with respect to time. Differentiating with respect to time. What we get, students? Derivative of L by derivative of t is equal to dy naught by dt plus 2 of dy2 by dt plus derivative of y1 by dt. Okay students, here it is the constant, length is the constant, so the differentiation becomes 0, and it is also a constant, that's why it is 0, and we get 2v2 plus v1. Okay students, again differentiating with respect to time, we get 0 is equal to 2 of dv2 by dt plus derivative of v1 by dt. As you know that v by t is acceleration, and we get the acceleration. It is 2a2 plus a1 is equal to 0, and we yield, okay, 2a2 is equal to a1. Okay students, here in this way you can relate the accelerations. Okay, here I am writing it as the positive because the accelerations are working in against directions. Okay students, let's say a2 is equal to a, then we get a1 is equal to a. Means what? This one moves down with an acceleration twice of this. Okay, here it has an acceleration of a, and this pulley, that means what? By means of this pulley, this one moves down with the acceleration which is twice of this one. Okay students, here let's find out the magnitudes of the acceleration, and I said it's a common acceleration it has, and also we need to find the tension. Okay students, here we got a2 as a, and now if you draw the free body diagrams, and it is m1g and it is m2g, students. Okay, if you draw the free body diagram of this one, the difference between the weight and as well as the tension provides the acceleration. Here in this case, okay, we are writing the FBD of m1. Okay students, it can be drawn in this way. It is m1g and it is the t. Here m1g minus t is equal to m1a. That means acceleration a1, that is m1g minus t m1 into 2a. Okay, students? Similarly, if you draw the free body diagram of this part, okay, it is T and it is the T and it is the 2T. Okay, free body diagram of M2 we are drawing. You can draw it like this. It is 2T is equal to M2G. Since it is moving up, 2T minus M2G is equal to M2A1. A2. That is 2T minus M2G is equal to M2A. Since A2 is equal to A2. Okay, it is the equation 1 and is the 2. Okay, students, we have to add these equations. It is M1G minus T is equal to 2MA. Multiplying with 2, what I get? 2M1G minus 2T is equal to 4MA. And we have this equation. Say it as 3 and 2. Adding 2 and 3. What we get? 2T minus M2G plus 2M1G minus 2T is equal to M2A plus 4M1A is M1. Isn't it, students? Then what you get? Here T get cancelled. G of 2M1 minus M2 is equal to A of 4M1 plus M2. And we get the acceleration. Acceleration of the system is 2M1 minus M2. Okay, students, of G by 4M1 plus M2. It is the desired acceleration, students. Okay, students, in this way we can find out the acceleration as 2m1 minus m2 of g by 4m1 plus m2. Then after we are going to find the tension in the string, students. Tension in the string. Okay, students. Here we are taking this diagram. If you draw the free body diagram, you will find is the tension. It is M1G. The difference of the two, M1G minus T is equal to M1, A1. Okay. And we wrote it as M1G minus T, M1 into 2A. We had the value of the A. It is M1G minus T is equal to 2M1 into 2M1 minus M2 of G whole divided by 4M1 plus M2. Okay, students? Then T can be written as M1G minus 2M1 of 2M1 minus M2 of G by 4M1 plus M2. Okay, students? Further, it can be written as T is equal to M1G of 4M1 plus m2 minus 2m1 into 2m1 minus m2 of g whole divided by 4m1 plus m2, and it is 4m1 square g plus m1 m2 g minus 4 m1 square g, here we multiply this, plus 2 m1 m2 into g, okay, by 4 m1 plus m2. Okay, simpler terms get cancels, and we get tension is equal to 3 m1 m2 g by 4 m1 plus m2. By using these relations, you can find out the tension and as well as the acceleration of the system, students. A1 is equal to 2a. A simple thing, students. This pulley is moving up. That means the length which is decreasing in this amount must be equal to the increasement of the length in this part of the string. Okay, let's say the pulley raised up to this one. That means it is the decreasement of the length of the pulley with respect to the string appears to be increasement in this. That means if it rises to a distance of 2y, then the increment would be in this one. Okay, here the increment is twice of that. That's why we get 2 times of acceleration all the time. Directly you can do that by practicing the problems. You can understand this thing in a right way. Friends, right now we did a 2 pulley system. Now we are going to do a 3 pulley. Okay, let's say it's a rigid support. Okay, students, from where we are suspending the system. It is a pulley, and we have one more. Okay, students, a string is moving over, and is passing over one more pulley. Okay, here is the weight which has been suspended, and it is connected like this. Okay, students, and one more weight we are hanging it. Okay, students, the same principle we are using here. Here, say it is raising up and it is raising down. Let's say it has an acceleration of a2 and it is a1. Okay, these are the fixed position, students, and these things doesn't change, but the remaining will changes. Let's say the length is equal to these parts we are taking. This remains constant. 1, 2, 3. Okay. Decreasement of these lengths appears to be increasements in this. Okay. Let's say this part is y2, and obviously it is y2 and it is y2, and this one is y1, students. Okay, it is y2 and it is y2. Okay students, we can write 3y2, okay, plus y1, and it's the constant length. So it is y0, it remains constant. Okay, again you differentiate it, you get dl by dt is equal to 3 of dy2 by dt plus derivative of y1 by dt plus, okay students, here it is equal to 0, 0 is equal to 3v2 plus v1 plus 0, again differentiating with respect to time, we get 3 of dv2 by dt plus dv1 by dt is equal to 0. Okay students, and it is the acceleration 3a2 plus a1 is equal to 0, or you can write a1 is equal to minus 3a2. Okay students, say this, the acceleration is equal to 3 times to this. Let's say it is a, and it is equal to 3 to a. Getting me students? In this way we can register the accelerations. Here if you starts doing the problem, you can understand how the acceleration can be calculated by counting the number of strings which are attached. Okay, practicing make you perfect in this. We got the acceleration. Then we have to find out the tension and as well as the acceleration of the system. Okay students, now we are using the free body diagrams. Let's see. For this, say it is m1 and it is m2 g, tension, tension, tension and tension. Okay, obviously it is equal to 2t. Okay, let's take FBD of m1. What you get is the tension, it is the weight. Okay students, though m1 is m1g minus t is equal to m1 into a1, that is m1g minus t is equal to m1 into 3a. Okay, and if you watch that, the second one, FBD of m2, what you get, t plus t plus t. Okay students, 3t minus m2g is equal to m2 a2, that is 3t minus m2g is equal to m2a. Okay students, let's eliminate one of the factors. Okay students, and we will get the tension and as well as the acceleration. I'm multiplying this equation with 3. I get it as 3m1g minus 3t is equal to 9m1a. Similarly, it is 3t minus m2g is equal to m2a. We are adding the equation students. What you get? 3 m1g minus m2g is equal to a of 9m1 plus m2, and we got acceleration as g of 3m1 minus m2 by 9m1 plus m2. Okay students, in this way you can find out the acceleration. Let's substitute this acceleration in one of the equations and we will get the tension. Okay students, in this way you can find out the acceleration and as well as the tension in a 2 pulley system and as well as the 3. Okay students, in this way we found the acceleration of the system. Let's find the tension. Okay students, you know that m1g minus t is equal to 3m1 into a. Already we did this. We are substituting that value. Okay students, further we are writing it as t is equal to m1g minus 3m1 into 3m1 minus m2 into g by 9m1 plus m2, and it can be written as 9m1 square g, okay, plus m1 m2 g minus 9m1 square g plus 3 m1 m2 g whole divided by 9m1 plus m2. These terms get cancelled. We get it as 4m1 m2 g by 9m1 plus m2. In this way, you can calculate the tension in the string, students.